Okay, so we shall start already. Yes. Last week, this one I asked you to go back and have a read on this one. Yeah, regarding the SCORE RM. Okay, source code, reverse engineering, re-engineering reference model. Okay, so this model actually is another model that we try to re-engineer the system, okay, by analyzing the source code and so on. So what is the purpose of this approach? Come. Is it one? Home one? VGA one? Okay. So now this approach actually is with the purpose of understand the needs of the software, how to rationalize the system, okay, and understand how to rebuild the software. So therefore, this model, okay, consists of 4 elements. You can see that the functions, okay, the medication, the documentation, and the database repository. Okay, so these are the 4 elements. And then from this model, we know that there are 2, 4, 6, 8 processes or 8 phases for this SCORE RM model. So we are going to start with the first one. Look at this slide here. This is a summary of each of the slides, each of the phases. Okay. So the first process or the first function, okay, so is called encapsulation. So is the what is happening in here is the management of configuration. Identify all those items, identify the source code, the items, okay, note their state, okay, perform an analysis on the items, okay, in the source code, okay, and also do a parsing, do some conversion, and generate a test case. What you mean by generate test case? To generate test case to test the existing system, whether the system is the existing system is performed correctly or not. Then transformation stage, okay, to rationalize the control flow. To means that to identify the control flows, okay, of the program, okay, and isolate the external entity. Those external entity that is connected to the existing system, we try to separate out, okay, so that we can know that, okay, which one is belongs to the existing system and which one is the external entity. Normalization, this one is more on, as you know lah, okay, normalization to reduce redundant data. To reduce redundant data. This is performing on the existing database, okay, to reduce redundant data, to identify the relationship between the data, okay, and also to check on the control, okay, how the data is being changed, okay, in which part or which logic the data is going to be changed, okay. Then we move to the interpretation phase, in which each interpretation phase means that we try to remove all those global variables, okay, and then try to identify the recursion functions and also identify those polymorphic functions. It means that those let's say functions will have many tasks, same name, okay. So and then read the program, okay, adding the command into the existing program to have more understanding on what the program is trying to do. Then come to this stage or this process. Abstraction, create the object hierarchy. Okay, means that to correct the object structure lah, and separate out the data from the operator. Okay, we need to know the data and group the operators. Interpret the object interpret object means that we try, when we identify those objects in the existing system, we try to map this object in the program domain. Understand? Okay, so make sure that this object is it really that suit to this domain or really that not so sweet or whatever. Okay, so causation, this stage is a bit special. Why? Because from the first stage or first process until abstraction, all this is the reverse engineering. Okay, to understand the existing system. However, from the causation here, this stage is a bit special. Why? In this stage, they consist of reverse engineering activity and also forward engineering activity. So causation specified action means that this, this program, okay, the function which is needed by the user. Okay, which function is needed by the user and which function is needed by the user to fulfill a certain requirement, and then also specify the software constraint. Okay, then regeneration, from what you have get, okay, you try to start to regenerate the detailed design from the abstract model. This is to start, this is the forward engineering already, and generate the test cases to test the new system. Okay, certification to check whether the software is ready, safe to be used. Okay, is it the software is conform to all those necessary functions and requirements. So these are the 8 functions or 8 stages of score RM model. Okay, yeah. And for the next chapter 7, okay, we continue for this from the chapter 6. Chapter 7 is regarding reverse engineering. Okay, so reverse engineering, so in this chapter introduces several techniques. First of them is the visualization and representation. Okay, please don't be misleading by this word. Actually, this is how this visualization in general, the upper here, in general, okay, is how are we going to understand the existing system structure, okay, by using a certain, what happened?
Mickey Mouse joined the campus.
Okay, so very sharp the sound. Okay, so this visualization actually is we try to use certain visual object to represent our system structure. Okay, why we need to represent it? Because we need to understand the system. Okay, so this is visualization. Now, however, you look at the second paragraph, visualizations with the S1 and the representation. Actually, this is the 2 terms under this visualization. What is the difference there? Representation actually is use a notation, a graphical notation to represent a single component. Visualization is use the we call the graphic representation to show the configuration of a set of interrelated components. Understand? What is to show one component, representation, and visualizations is to show a set of interrelated components. That's it only. Okay? Now, what are the when we want to evaluate the representation, okay, or create the representation, these are the key attributes that we need to focus on. I guess it's too small really in the words. Okay? First one, individuality. Different component types should be presented by various visual styles. Different component is better to use different style to represent it. Distinctive appearance immediately distinguishable as either different or the same. So make sure if you want to show different component or different item, so make sure that when the user read it, okay, is able to differentiate. These are the 2 different things. Understand? High information means that not flooded with all the information, with sufficient information. Understand? Okay? Low visual complexity don't allow too many graphics, okay, in your model or diagramming or representation, so that the focus of the audience will be distracted, and somehow you have too many graphics is become very difficult to read. Understand? Scalability of visual complexity. This your representation of your system structure is allowed the remove or add of information easily. Okay. Flexibility for integration into visualization. Allow easier reorientation, position, okay, shape, color, size, changes of this attribute, okay, on your representation or visualizations. Suitability for automation, allow automation for generating representation and visualization. What is the requirement for designing a visualization? Simple navigation, easy to navigate, okay, from one level to another level. High information content, but sufficient, high information content means sufficient information, but not flooded, understand? Not over flooded the information, sufficient only, okay? Low visual complexity, varying level of details, high level, a bit lower level, a bit detail level, and detail level, understand? You cannot put everything inside the same level. Resilient to change, allow changes, okay, but these changes will not affect others, okay? So this is the resilient to change. Effective visual metaphor, use metaphor for better understanding. User-friendly interface, integration with other information sources. Okay, let's say for example, a shape that represents a module. Okay, this module, when you click on that, you link to the code. Understand? Okay. Good use of interaction. Okay, provide different views as you study in your SDA. So the 4+1 view, they are one of the example lah. Suitability for automation, this is the same one with just now previous one. These are the program metrics that we use to measure, okay, or we are going to use during the reverse engineering. Lines of code, global variable, cyclomatic complexity, read coupling, write coupling, address coupling. Okay, so these are the metrics. What is a read coupling? The number of variables read by a program unit. Okay, write coupling, the number of global variables accessed or write by the program unit. Address coupling, the number of global variables, okay, where the address are extracted by a program unit but not involved in read-write coupling. Fan-in, the number of other functions called a given function in a module. Fan-out, the number of other functions called from a given module or function. Hall stack complexity, this hall stack complexity actually is very interesting one. This is the second metric complexity that we use. From the SQLT, you learn cyclomatic complexity. From this one, okay, that introduces the hall stack complexity. But this hall stack complexity, okay, is like that. You calculate the number of distinct operators used in the program, and then you calculate the number of distinct operands used in the program. By these two figures, then you can calculate all this effort, efficiency, program length, and so on. Understand? So maybe if in the tutorial we have a bit time, then we can I can show you, okay, how to calculate the hall stack complexity. For the function point, actually is the measurement of the number of business functionality that in your program. Sometimes when you want to measure the program size, besides using the lines of code, we can use the function point. Understand? Okay. This is another reverse. This is the metric, okay. Response for a class. The maximum number of methods that can be run in response to a message received by a specific class. Means that when the class, okay, receive a message, okay, the maximum number of methods that can be execute. Okay, so how to measure it? Sum of the number of the method implemented in the class and the number of method available to an object class owing to inheritance. Sum up these two. Lack of cohesion in method. Lack of cohesion method means that this is a cohesion in method means that how the method or and the attribute in the class is grouped. Understand? So means that how this method and the attribute within a class how close they work together to perform the task. So this is the cohesion in methods. Okay. So how to calculate? Calculate the percentage of methods in a given class that use a specific attribute, and then subtract the average of those percentage from 100%. The higher the figure of this LCOM, means that the poorer the design of your class. Understand? Means that those class and the method attribute they did not really used by the method one. Okay, so in this case, you may consider split this class into different classes. Okay, so this is the metric for LCOM. Okay. So coupling between object class, means that two different classes, which is not inheritance one, two different classes, in which they are linked together. Okay, so let's say class A and class B, they are different classes. So how these different classes link together? Then if they link together, maybe access maybe imports right, isn't it? So in this case there exists a coupling between them. So in this case, this is meant by coupling between object class. Depth of inheritance. How long is your inheritance level? Understand? Class 1, class 2 inherit from class 1, class 3 inherit from class 2, class 4 inherit from class 3, how many level? How depth, of your inheritance. Number of children, so means that a class got how many subclass that inherit from it, okay? Now we come to decompilation. What's meant by decompilation? Decompilation actually is to change your execution code back to its source code or back to the intermediate language. Understand? The other way around. When we compile our program, right, from the source code, we compile in intermediate language, and then when we run it, become a machine code. Am I right? Okay, exe file lah. So for decompilation, it's the other way around. Okay. So, but however, decompilation has the other meaning in terms of software security. Okay. So decompilation can be treated as a threat in a software. Why? Because your source code has been reviewed by others, third party, by performing the decompilation. Okay, and then how to avoid this, or how to make the third party not so easy to decompile our coding? Maybe you can use this technique. Obfuscation. Okay, what you mean by obfuscation? This is to make your coding become very complex. Okay, when they try to decompile the code into a source code, maybe some of part of them not able to do it, and even though they can decompile back, the code become very like so messy or very complex, so that the people not easy to steal your code. Understand? Okay. So then, decompilation, is it a reverse engineering? Yes. Decompilation definitely is a reverse engineering activity. Why? Because from lower level machine code back to the source code or intermediate language. So this is definitely a reverse engineering activity. However, reverse engineering is cover so many activities, and decompilation is a part of that. Understand? Decompilation is only happen in the source code level. Whereas reverse engineering cover wider scope from source code to the conceptual model. Understand? Okay. This one, I guess I don't need to do. I already explained. data reverse engineering. This one is how are we going to perform a reverse, understand or examine the existing data or database, okay, in order to retrieve back the pure, the pure clean data from the existing data. Okay, so there are two stages: recovering data assets that are valuable, that are useful for the new system. Reconstitute the recovered data asset to make them more useful. Okay, modify the data model. Okay, so that it become more useful in the new system. The purpose: knowledge acquisition, understand, okay, the existing system, how the system works, understand how the data structure or model in the existing system is. Tentative requirement from understanding the data or performing data requirement engineering, more or less you know that, okay, what are the requirements of the existing system, okay? And what kind of, maybe we can also identify what are the new requirements for this system. Documentation, for documentation purpose, okay? If the programmer or the developer is no longer exists. Integration, okay? Why? Because from your reverse engineering, data reverse engineering, they are going to produce a data model from the existing system. Okay, so then this data model is for what purpose? Okay, it shows that, okay, this software, what is the tentative requirement? Okay, and also this data model provide, okay, how to say, allow us to know that, okay, how to integrate with the existing software. Understand? So, and then secondly, he shows the tentative requirement, shows that, okay, how the existing system is functioning. Okay. Data administration, third purpose, allow us to manage data effectively and efficiently. Data conversion provide us to convert from the existing model to a new model. Maybe your new system may use different database there, different type of database there. Understand? By deriving this data model, it allows you to assist you, okay, in easier to convert from the old one to the new data. Software assessment provide one of the criteria to assess the software product. Okay, how good is the software in terms of product data assessing? Okay, how fast is the data assessing? How to maintain the consistency? Okay, allow us to do the evaluation. Quality assessment. Okay, this one is to allow same thing lah. Okay, allow us to assess the quality. Any error in the design of the program or the data model. Component reuse. When you do reverse engineering, some item you identify during the reverse engineering, this is a possibility, okay, for reuse purpose. Maybe this item, okay, you reverse, you get the item, then this item can be reused in other project, or even though can be reused back on the new system. This data reverse engineering, two main process: data extraction and data conceptualization. Data extraction means that, okay, you try to examine, analyze the existing data, okay, and then to obtain the data structure of the existing data, okay, the data structure. Maybe you remove all those redundant data, okay, get all those valuable data and important data, okay, to get back their data schema. And for the in this stage also, you also how to say, performing the DDL, data definition language. Okay, so in this data definition language, okay, you are able to generate the schema of the database. I guess you know what is data DDL, right? Isn't it? It's those database language that used to create the schema one. Have you learned this one before? During your data, I guess got right, isn't it? Okay. So, and program analysis, examine the source code, whether is it additional data is required. Okay? And then data analysis, then you analyze the data also, okay? For other files or other database okay, to get the data structure. Schema integration, okay? So means that sometimes your existing system may integrate with different type of database, more than one database, or maybe more than one data file. Okay. So in this case, you need to analyze it. Okay, because different database have different schema, and then you try to see how this schema can be integrated together. Now to the second phase, conceptualization. Okay, so once you have get all those existing data structure, data schema in detail, okay, then from here you are going to create a more higher level, a conceptual level that represent the data structure. Okay, so in this case, then first thing is making the schema ready. Okay, so now what are the first steps? The original schema, okay, might have others valuable structure. Okay, what are the key fields okay, what are the things can be removed, and then try to look at the name of the data, mean the field okay, that is it the name can be renamed to be more readable, more understandable, and then try to read the schema, comprehend the schema, whether the schema need to be restructured or is it the schema is appropriate or not. Schema and translation. Okay, so this is the step where you try to we try to reverse back, okay, we try to reverse back to the original data model, because throughout the using of the existing system, the data is the data model or the data is being changed, okay, or any field is being added, and also the field may be removed or modified. So in this case, we try to rewind back to the original schema as possible, but it's not 100% one only. Okay, schema de-optimization. What do you mean by schema de-optimization? Because sometimes when we use the system database, we purposely add certain data or field into the database. Why? Because it's the needs of the program. For the programmer, easier to do the program. Yeah, it's happened also. But in this stage, we try to remove all these things. Okay, as I said, try to remove the original schema. Okay, as much as possible. Then conceptual normalization. Okay, so instead of you need to identify the relationship. Okay, first one, replace some entity type by relationship type, means that we try to identify the relationship between them, replace those unwanted attributes with a more better or more meaningful one, make is a relationship explicit, standardize the name. Okay, so the field name, standardize the field name. So this is the conceptual normalization. Okay, so in here we identify the relationship, tidy up the name, okay, make it more readable. Sometimes technical name is quite difficult to read. Okay, so in the conceptual level, we may need to use a general English in describing the data. This is the diagram for the reverse engineering methodology. So at this side is the data extraction. This side is the data conceptualization. So at the end, what it's going to produce is the conceptual schema of the existing database. Okay? Then from this conceptual schema of the existing database, then you may start to do your forward engineering. Understand? Okay? So this is the reverse engineering, data reverse engineering methodology. Okay? Reverse engineering tools. This is some basic structure for reverse engineering tools. Definitely, when we want to do a reverse engineering, we definitely need some tools. Let's say, for example, we may use Visual Studio, okay, to do the reverse engineering code to the task, okay, or maybe we need to use certain tools like dviewer, okay, that we can reverse engineer the NoSQL databases back to the data model, okay. We can use Visual Paradigm, not online edition, Visual Paradigm Enterprise edition to do the reverse engineering. Also can, understand? Depends on which part. Because reverse engineering, we can apply in data, we can apply in code, we can apply in design. It depends on what are the things we want to reverse, okay. And this is the basic structure of reverse engineering tools. You can see that a software product, okay, for example, the code. So code here, with the reverse engineering tools, we analyze the code and understand each of the character meaning, okay, and then from here, they will store into information base. Based on the information, they compare, and then what is the meaning and so on, and then go to the view composer, generate, okay, the necessary representation and display to the developer. So this is the basic structure of the reverse engineering tools. And these are the examples. Okay, these are the examples of reverse engineering tools. Okay, that's it for our chapter 7. Any question? No.
Why everything feels so fast one?
Huh?
Why it feels so fast one?
Sorry?
Why it feels very fast one?
You know, why can't so fast?
So fast I
speak so fast already.
yeah, so fast I don't know what is important, what is not important.
Important one Actually, for this one, important one. For the important one, you need to know what is meant by data reverse engineering. Okay. For the metric, you need to know what is the metric okay. And I guess visualization and representation, this one, it's just for your knowledge okay. But data reverse engineering and what? Okay. So this is the point of this topic of this chapter, this topic. Okay.
And what come again? What again?
Data reverse engineering. Yes.
This entire chapter, right? So everything important?
Data reverse engineering.
Oh, here.
But this one, important important meaning is not for the exam, understand? Okay. So this is chapter 7. So any question class?
刚才有什么？只有这个。
Midterm cover until chapter 5
他
only.
讲那个 visualize 不重要，剩下的比较重要。visualization 那些不重要。
Anything else? Then nothing. Shall we continue with chapter 8? This is a very interesting topic. Chapter 8, Legacy System.
Yeah, Cobol and Fortran.
Legacy System. Shall we cover this one? Is it too fast? Or the speed? Never mind, cover a bit. Okay. Okay, legacy system.
engineering 重要。
What is a legacy system, class?
Data reverse engineering 重要。
What is a legacy system?
COBOL and Fortran.
That one is a language.
Program written in those languages.
That one is what? Fortran and COBOL. Fortran and COBOL is a third generation programming language, right? Okay. So, what is the legacy system?
Very, very old system.
Very old system. So then, can you guess what is the characteristic of a legacy system?
Very hard to maintain.
I have to stay here because my leg is very painful. Okay, so chapter 8, legacy system, right? Legacy system is those systems very old, am I right? Okay, so what is the characteristic of legacy system? Where is Carson?
Very hard to maintain.
Where is Carson? Didn't come.
Jungle.
Tamesh come. Yes, Tamesh. Give me one characteristic. You guess lah, remember? Just guess. What is the characteristic of a legacy system? Let's say you have a software system. Okay? Very old one. Then what is the beside old lah? Okay? Old means that what kind of characteristic that describe old? Yes, Tamesh. Huh? Sorry? Less secure. Okay. And then how about is Aloysius here? Aloysius. Hi. How come? Wei Chong. Don't have? How come? And Brian. Huh? Sorry?
Brian 在哪里？
Who is here? Who is in the... Hold on. No Brian here, man. Why you laugh?
Nothing.
Brandon?
Huh?
I think got two Brandon, right? Yeah.
Brandon Tan.
Never mind. Lobbing. Yes.
What is lobbying?
Lobbing. Yes. What is the characteristic of legacy system? Just guess. Don't look at the slide.
A system that is very, very old,
Yeah, how to describe old?
over 10 years.
Over 10 years. Okay. More than 10 years. Okay. But for now, okay. So the technology evolved so fast. I think 5 years the technology is already obsolete already. Okay. So yeah. And then Yosen. Yosen, yes, another characteristic of legacy. Just guess, no need to read the slide. Guess only. Outdated, right? Outdated documentation, outdated language, outdated technology. Okay? So, and then, Renisha. Yes. Difficult to understand. To expand, yes. Why difficult to expand? Hold on. Hema. Yes, why legacy system, old system difficult to expand? Yes. Sam. So, Sorry? Do not have the skill, difficult to expand because the new developer do not understand old technology. Maybe, okay. So I want to hear from others. Yes, at the back. Brother, you raise your hand already. Yeah, sit in the middle, the last row. Yes. This row, sit in the middle, I don't hide yourself. Okay. Yes, why is difficult to expand for old system? Difficult to expand more. You cannot add in anything anymore. Yeah, why like that one for old system?
Lack of support.
SEM is already mentioned. Yes.
How to add in?
Yes, brother.
Lack of software support. That's the main reason.
Outdated. Just now your classmate already mentioned this point. Got another point or not? Today I forgot to buy something here. Okay. Next week. Okay. So yes. I will ask class rep. Class rep. Yes.
Because the whole system is complex.
Complex. Why complex? Because so far months after implemented, the system is being modified. Okay, very complex, so difficult to expand. So these are the characteristics of legacy system. Understand? So for this chapter, for this chapter, you need to do a brain, mind map. Okay, so think of the characteristic of the old system. That is easier for you to understand this topic. Now let's have a look on this one. Okay, according to Brody and Stonebreaker, so this is the explanation of legacy system. Those IS information system that are difficult to modify. Okay, and also difficult to change to meet new requirements. So this is called the legacy system. This is the features, the characteristic of legacy system. Large with millions lines of code, aging more than 10 years. But I guess now more than 5 years is already obsolete already, technology. Then written in obsolete language. What kind of language is already obsolete? Anyone can give me one example?
I give you two already.
Fortune still being used. Cobol is still being used until now.
Not in the average company, in like banking only.
Sorry?
In companies like finance institutions, but not.
Cobol is still in, I think it's used in banking.
Yeah.
For certain bank. Okay. Then, not obsolete.
ASP.NET.
ASP.NET. ASP.NET is a technology, it's not a language. Right? Yeah, right. ASP.NET, you can use C#, VB.NET, and whatever. Okay. So, what kind of language is obsolete already? Any idea? Yes, who is very good in programming? Brother. Yes. Very good in programming one. Not Yongxin. Yongxin is one of them. Okay. Then, at the back, yes. Second row, this side. Okay. Yes, what kind of language is already obsolete already? Any example? Yes, anyone? Do you ever do a finding on what language is already obsolete? No more use for today already.
OpenGL.
That one is because the OpenGL is not so famous subject, so doesn't mean that it's obsolete. Okay. So yes.
ASM.
How about D-based language?
Never heard of that before. Very obsolete lah, definitely.
Have you heard D-based language before?
It's so obsolete, I never heard of it.
Actually, this D-based D-B-A-S-E donkey B-A-S-E D-based actually is a database system, but it has its programming language also. It means that combine database with the programming language. Okay, but so far, so many years already, I didn't heard that any company is still using D-based. I guess it should be obsolete already. But you can check lah, okay, whether D-based is obsolete or not. Last time I studied, I'm using D-based on database programming, okay, D-based. So what I know is until version 5, D-based 5.0, okay. But however, so many years I did not hear any D-based anymore. But I'm not so sure whether it's already obsolete in Malaysia only or it's still available in other countries. Okay, it's a very, very old language and database system. Okay, you can have a chat on that lah. Okay, it's really obsolete already. Now,
Obsolete programming language, does that include the modern programming language but older version?
possible, yeah.
Like if someone is using Python 2 point something instead of the 3 point something that we use now.
But in general, we still mention as Python, right?
Yeah.
Don't know lah. Still here lah. Still survive lah. Still survive lah. Okay. So and then what is that lah? Difficult. Lack of consistent documentation. Yes, lack of documentation. And then poor management of data. The database is quite messy, or maybe they're just not using database. They use a text file to store data. Okay, so the how to say, the changes throughout the years have spoiled the construction, the architecture of the system already. Okay, so difficult to expand. Run on old processor. Okay, even though the system is still working, you install in the new system, maybe he cannot fully utilize the hard disk. Understand? And support team is completely relying on the experience. They are based on the experience to maintain the system rather than based on the documentation. Okay. What are the solutions for legacy system? Freeze means that don't carry anything, okay, further work on an LIS. LIS means that legacy information system, okay. So outsource other supplier to maintain or to support the system. Carry on maintenance by yourself, okay. Discard and redevelop throughout the old one, develop a new one. Wrap. What is a wrap? I guess I have explained this term before, right? Wrapping. Okay, what is a wrap class? Yes, Ryan. Not Brian, Ryan. Who is Ryan? Wow, now student very clever. Okay, they call the name. They know lecturer don't know him, not recognize him. They just quiet. Don't know who is Ryan. Okay. Yes, and then, yes, brother, your friend, Kamesh, yeah, your friend, yeah. What is rap? What is a rapper? What is a rapper? Yes? Okay, then come to this side. What is a rapper? Nicholas.
Got someone named Nicholas.
Got Nicholas here. Nicholas, right? Okay, Nicholas. Never mind, I asked you already. Okay. Anyone can tell me what is a rapper? JSON, yes, it's a layer of code to cover a function, a module, or a software or subsystem. Understand? So this is a wrapper. Migrate. One of the solutions is to migrate the old system into a new platform. Okay, maybe the system need to change also lah. Okay, so this is a migrate. What is the wrapping here? You can see that wrapping is a black box re-engineering activities when we apply a layer of code to surround or to cover the target function, module, subsystem, or system even. Okay, so that everything we do is through the wrapper. Understand? So this is the wrapping. Okay. Type of wrapping. This one is very easy one. Database wrapping, system service wrapping, application wrapping, function wrapping. What is the difference? The difference actually is the scope only. Database wrapper is to wrap the database. Okay. Service wrap the service. Application wrap the whole application. Function wrap a certain function. That's it. Okay. It's just the difference is the concept is the same. Just that the difference is the scope of the size of wrapping only. Okay. So now we come to, shall we start this one? No lah, I think I stop here. Okay, I stop here. Hey, not yet end. We take 10 minutes break, then we come back to the quiz. Okay. Okay. Who is this person? Spam caller. So you can see that now our what we call privacy, make of privacy, good of privacy. How can they know our handphone number? Even though you know my name also. Recently, who are you? I'm from where? Then I will ask, how do you know my name? Yes, they make of privacy. Once you share in the internet, everyone will know your info already. Okay, class. Okay, class, you may join this quiz. Huh? This week or? I think this week Friday can. After 3 this week can. This week should be okay. Next week cannot. This week Friday can. Okay, have you joined the quiz already? All join, yeah?
Hey, how come so few students? 33 participants. Here got 33 man. More than that, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 40 something students, yeah. 40 something students, man.
What is that?
Yes, what is this?
我看到那个，我很难，不是我，
Okay, I'm going to start the quiz.
取的名字很文化
1, 2, 3.
有两个这个。
是两个人想攻击我。
Who is Abang Sakamoto? I see I got Brian one, I say, who's Brian?
一个白二。
Conceptualization 也可以 conceptual model 是 conceptualization 的 give conceptual model 是啊。
4 is 27. Miss, say something. Jessica, who is Jessica? Monte, Denisha, you guess what can I? Korean word also got.
这是你这些个。这是他这个。
白二，
Oh, you're Brian.
No. This is Brian Pang.
白二干。
Brian Pang.
What's suddenly this Brian so famous?
Huh? Brian Chu. 这个他们要会背自己。
也因为讲课才一起做。
这样让我生气了。还不好意思。姐，我有 wrong。Jessica。这样子。
Next question.
What can I say? Say nothing. Yeah. Anyone has modified my quiz? Okay, so have you completed the quiz already? Not yet.
我的名字就可以出现在那里。差一点。
Okay. Hey, got answer got show to you one the quiz. Did the answer show to you for the quiz what? Okay, class. Anyone haven't finished the quiz yet? All completed, alright? Is it? So all completed, then you can refer back to the answer given on the quiz. Okay. So then next week we are going to have our mock test. I will prepare one question. Okay. So I will show on the screen. Okay. Maybe two lah. See lah. Okay. I don't know whether got time or not. Okay. Sufficient time because we need to do lecture also. Okay. So that's it lah. Okay. So we are going to check. You are going to check your own answer. Okay. For on the spot after the test. Okay. Yeah. And please bear in mind, week 8 is your midterm test. Cover chapter 1 to chapter 5. Okay. Please go and get ready. Okay, that's it for today. Yeah, I'm going to end the quiz. Yeah. Yes. Who is Rob Ruti? Who's Rob Ruti? Raise your hand. Who? Anyone call Rob Ruti? Papa Chong? Okay. So, let's see.
sexy lady.
Sign up. Okay, I see you next week on Friday.